Hi everyone, my name is Stas Lebedenko. I'm a senior software developer at Sigma Software, active geek in Ukrainian .NET and Azure communities, and co-organizer of Odessa.NET user group. And today I want to share my experience with Azure SQL Serverless solution. It was released during Microsoft Ignite, and so I decided to create a first proof of concept to test it with production-like loads. For this exact purpose, I have created GitHub repository with demo application and prepared Azure Client script for you. So you can just download this application, test it for yourself and for your particular scenarios. Let's talk about usage scenarios. It's unpredictable load that can spike. And if you're using Azure Functions or other event-driven solutions that is using SQL Server, this can be a life saver, because compute can be scaled on demand and can be scaled quite fast. Yes, there is a problem of the cold start, but it can be mitigated with time-triggered Azure Functions at 8 a.m. in the morning, or it can be triggered with Azure Logic app, which is what I'm doing in production. And so you can omit cold start issues and long responses during the day. My estimated calculation, Azure SQL Serverless can save up to the 2/3 of company budget if you are running workloads during the work time. Also, there is an issue with burstable load. If you have some ETL processes that is integrating data and saving it to your SQL Server instance, you can download your data quickly, and then in the 1 hour, database will be scaled down to the 0. And one of the important things here is that you should be aware about client patterns usage, and you should be architecting this usage. Basically, if Azure Functions on consumption tier is auto-disposing after 10 minutes of inactivity, but static web applications that is deployed to standard app service plans can have always on settings that will keep application warm and keep application connection pool ready to connect with your instance. And this will prevent scale down to 0 as well. And this will result in continuous execution of your Azure SQL Serverless instance. So let's start with the repository and scaffolding of the infrastructure. I want to start with the demo and share my takeaways about usage. So let's start with command line interface via Bash and Azure Client. Now I will switch back to the GitHub, select Azure Client script and copy paste it here. And now while this script is executing, I will briefly explain commands here. Everything starts with Azure Resource Group. On the next step, I will create Azure Storage account and prepare account access key with connection string. The next step is application insights for logging all the exceptions and connection metrics. Then time comes for the Azure Function app. I'm creating managed identity here, but it's not used during this demo. Now it's time for Azure SQL Server with serverless database. Azure SQL Server itself is a typical command, but Azure SQL database create have additional configuration here. It's compute model serverless, it's family generation for the compute, it's generation 5, and capacity here. Capacity is the maximum amount of vCores that can be deployed for your auto-post delay represents minimum number of minutes, it's 60 for your database vCore dispose. But this value is heavily affected by geo-redundant application if you set it for your database, and also long-time retention backups, because they need the time to sync all the data. The next step, it's the firewall outbound IPs. I am setting them for Azure Function app. And the last step is to prepare connection string and password and just set it directly to the function application. I'm intentionally not using Azure Key Vault to save some time for this demo. And now, as you can see, Azure Client already executed, and we can see a new resource group, Azure Advanced Calendar. And so we can select our database. And then we can open configuration of the database and see what we got as a result of Azure Client Script. So first thing is the preliminary summary of the cost per storage and execution time. We can adjust our configuration right here, set maximum cost up to the 16, but from my perspective 4 is good enough. And the minimum vCore is the amount of resources dedicated on database start. The memory limit is 3 gigabytes per vCore. And automatic stop time is equal to the 1 hour. Let's continue with the demo and see how it can scale. Now let's connect our demo application with the Loader.io account and publish it online. Then we should copy paste this URL and check it. Yes, it's working. Copy. Add new host on Loader.io. Next, click Verify. Now we have our token. Let's copy and paste it to our C# project. Request route. Loader activation function is anonymous. So you should be aware about this and disable it afterwards if you want to load tests for free and cannot validate your domain by other means. Okay, let's save it. Then let's switch back to the Azure. Let's download the publish profile. And now let's right click on our solution and select publish. Select start, select import profile, and find the downloaded profile on the file system. Now profile is selected. You should be connected to your Azure subscription with your Visual Studio account. You can double check and connect it via Cloud Explorer. So let's publish our application. As you can see, everything is published now, so we can go to the Loader.io and try to validate our application. But first, we need to migrate it. For the entity framework migrations, I'm using commands that is included in the DemoDB context file. So let's copy paste first one and run it. Migration is created now, so let's proceed with applying migration to the database. Important stuff is to set your SQL Server password and connection string to your environment variables. And you can just copy-paste command setx with connection string and password from the Azure Client Script output. Now let's execute .NET-AF the database update. And now, as you can see, small obstacle, but we should add our local IP address to the firewall. Let's do this. Let's find firewall here in SQL Server instance, firewalls and virtual networks. Now let's switch back to Studio and run apply migrations. Yeah, everything is done. Let's go on with the testing of the application. Yeah, it's green, great. Now let's create a test. For the test proposals, we should use URL from our function app. Here you should open a load test function. And then just click open function URL, copy it, and paste it here without URL prefix. That's it. Let's click run test. Some requests are going in, and let's open application insights and Azure SQL Serverless database to observe their behavior. Click application insights inside Azure function, and then just click live metrics stream. Then we will select our resource group and open our SQL database. And now we switch it back to the overview of this SQL Serverless database. And now we can see that our small load tests resulted in vCore seconds. And we can apply the cost of the configuration blade to these vCore seconds that we use, or even create alerts. So now let's run more intensive test. Let's edit. And select clients per second. So let it be 100 clients per second. Let's hit run test. Let's see how many instances we have of the Azure functions. Now we have 12 servers. Now let's edit it briefly and see how SQL Server can handle 200 clients per second. Now in live metric stream, still 16 servers online. And now with this bigger load test, we can see the gap in responses when additional instances or records being added to the SQL Server.
And as you can see now, the database was stopped right after 60 minutes of mine usage on the previous day. As you can see, the overall amount of vCore seconds is around 6,000, and all of the time a database is stopped. So this is the main benefit scenario for enterprise applications such as auto-pausing and burst load for Azure functions. And right now we will test the cold start of the database. So as you can see, no request is passed in, and we start the test again in 1 minute. As you can see, the database already started and success response count is increased. And live metric stream provides response data.
Now let's talk about things that will prevent scale-in functionality of the Azure SQL Serverless database. First thing is the Azure geo-replication. Basically, if you enable it on the constant basis, you will not see scale-in down to 0 because of the target SLA provided by the Azure. So all your replicas will be available in different regions, and changes will be synchronized on the constant basis. The second thing is the long-time retention backups. Azure SQL Server long-time retention backups are available from backups blade of the SQL Server, not from database. As you can see, the file configuration is the 4 point-in-time backups now is equal to the 7 days. And if we will select this database, we can choose long-time retention backup policy. But you should adjust it carefully so it will be aligned with your daily work usage of the SQL Serverless database. So Azure SQL Serverless can be quite useful in particular enterprise scenarios. You should always use proof of concept solutions for load testing. You can get this demo solution from my GitHub and test it for yourself. Actually, I think that testing some scenarios by yourself is the most efficient part of learning and getting up to speed with new solutions. I hope you enjoyed this demo. I will leave a QR code with a link at the end of this video. And I suggest to run a test by yourself to understand will it fit your exact scenarios. I want to thank you for watching this short demo. I want to thank Gregor Sati and Richard Hooper for making this possible and for organizing such creative and interesting event. And Merry Christmas, everyone. Cheers.